So now let us see the electromagnetic spectrum. We have seen the electromagnetic fields are formed when the electric charges accelerates, decelerates, whenever there is a time varying electric fields, time varying magnetic fields, then electromagnetic waves are formed. The frequency and the wavelength of these electromagnetic waves vary over a wide range, and it depends on the source which creates these fields. So this range of frequencies and the range of the wavelengths is discussed in the whole electromagnetic spectrum. Let us see. Now this is the range of frequencies from 10 to the power 2 to 10 to the power 4 onwards, and this is the range of wavelengths 10 to the power 6 to 10 to the power minus 16. This is a very wide range of wavelengths and the wide range of frequencies over which electromagnetic waves possess. So here you see this is the visible wavelength which we all are familiar. This is 4000 here angstrom is there, 4000 angstrom and 7500 angstrom. This is for red light and this is the violet light. The whole entire region is for visible light, which occupies a very small window of the whole electromagnetic spectrum. The wavelength of these visible is nearly 10 to the power minus 6 meters and nearly 10 to the power 14 or 13, 10 to the power 15 hertz is the frequency of these waves. Now these are visible lights, and beyond this R we have infrared, and after infrared we have radio waves, and this side after violet we call this ultraviolet rays, and then X-rays, and then gamma rays. So gamma rays have a very short wavelength. These wavelengths, that here it is shown atomic nucleus, that is the size of atomic nucleus. Here the diagrams show the order of these wavelengths, atomic dimensions. So here 10 to the power minus 10 means X-rays. So the wavelength of these X-rays is in this range. The order is this. Here biological bacteria and viruses have this order, and ultraviolet wavelengths you can see here has a wavelength which match the dimensions of virus and bacteria. And radio waves, their range is very large. They are as large as 10 to the power 6 meters. Their wavelengths vary from 10 to the power 6 meter to 10 to the power minus 2 meters. 10 to the power minus 2 is our finger. This finger is so in this range, and as large as, so you see here, as large as mountains. So 10 to the power 6 means the radio waves has a wavelength of the order of 10 to the power 6 meter. So this diagram tells the width, the range over which, the range of frequencies over which all these electromagnetic waves vary and the wavelengths vary. Now here also in the same, in this slide we have shown here in this format that how the gamma rays, the wavelength become short, ultraviolet X-rays somewhat better, ultraviolet somewhat more. As we go to infrared the wavelength increases, then microwaves the wavelength further increases, radio, and extremely low frequency radio waves. And here are shown the sources which produce these waves. Now gamma rays are produced by radioactive sources. Here X-rays are used in medical diagnosis and non-destructive testing of materials. They are produced when multi-electron atom, when inside multi-electron atom the electron de-excites from higher energy levels, they emit X-rays, or when fast moving electrons strike a solid target, they emit these rays. Ultraviolet rays are produced in welding arcs. Here visible light is there. Infrared light can be produced by heater, radiant heat. Then microwaves, that is used in microwave oven cooking. This radio waves in radio transmission, and next this power lines also radiate some energy that is into radio waves. This is the same diagram with. Now let us see radio waves. Radio waves, here you see Their wavelengths vary from 3 kilometer to 30 centimeter. This is the wavelength of radio waves, 3 kilometers. Amplitude modulated radio waves, the radio waves, the TV waves lie within this range. FM, the wavelengths for this FM radio is 3 meters. And you see, longest wavelength is of electromagnetic waves is radio waves. Radio wave has the longest wavelength of electromagnetic wave. And what are its uses? In TV broadcasting, we use radio waves. In amplitude modulation and FM broadcast of radio, we use radio waves. For heart rate monitors, cell phone communication is using radio waves, and magnetic resonance imaging used in medical diagnosis uses short radio waves with a magnet to create an image. This is the image of a MRI scan. Next, microwaves. Now you see the microwave region of electromagnetic spectrum, the 0.3 centimeter to nearly 300 centimeter wavelength these microwave bands have, and they are used in Bluetooth, Wi-Fi. Their wavelengths from 1 millimeter to 1 meter. Uses microwave ovens. In microwave ovens, microwave is used. These waves has a wavelength, has the frequency which match with the resonant frequency of water molecules. As a result, the water present in foodstuffs absorb this microwave energy and are heated without wasting energy in heating utensils. Now it is also used in Bluetooth headsets, the microwaves. Bluetooth wireless internet, that is Wi-Fi, also uses this system, and radars also use microwaves for detection of moving objects. GPS system uses microwaves for navigation. Next is infrared, and infrared region, it has 300 micrometer to nearly 3 micrometer wavelength range, and it is used in night vision goggles, remote controls, heat seeking missiles, and naturally in nature some snakes uses infrared radiation to detect their prey. So nature and we are also now using infrared radiation for our use. Now visible light, the range of visible light is from red from 7000 angstrom, that is 0.7 micrometer, to violet, that is nearly violet, that is 4000 angstrom, 0.4 micrometer. So this entire range is for visible light and our eye is sensitive, especially in blue green, in yellow green region. In this region our eye is most sensitive. So visible light, we all human beings and all animals, their eye are adapted for visible light. This is the only part of electromagnetic waves which are detected by human eye. Violet is the highest frequency, red light is the lowest frequency. Now ultraviolet. Now ultraviolet portion starts from 3 nanometer to 0.3 micrometer, and they are absorbed by ozone layer. Shorter wavelengths, they have shorter wavelengths than visible light. Their uses: black lights in photography. Security image on money uses the ultraviolet lights, and they are very harmful to human beings. Used to sterilize medical equipment. Too much causes sunburn, we get sunburns. Extremely high exposure can cause skin cancer. Now X-rays. X-rays are generated when fast moving electrons strikes a solid targets. When they are violently scattered, X-rays are emitted, and the range of wavelength is from 0.3 nanometer to 3 nanometer, and or in angstrom we say 0.1 to nearly 100 angstrom, and they have very high penetrating power. They have high energy, high penetrating power, and small wavelength. They can be used in medical imaging. You can see the X-ray of this. This is the neck portion. This is used in airport security. Moderate dose is used in airport security system. And next is the high frequency short wavelength gamma rays, and they are produced smallest wavelength, highest energy electromagnetic waves. They are used in sterilizing medical equipment, cancer treatment to kill cancer cells, and that's all.